What is up, guys? We're going to be taking a look at this lab, Reflected Cross-Site Scripting with AngularJS Sandbox Escape without strings. There is a little bit of context and history that will be relevant in fully understanding this lab solution. For example, we need to know what the AngularJS Sandbox is, what is a sandbox escape, and what this has to do with cross-site scripting. We'll get into those topics when it's relevant in the flow of solving the lab. For now, we'll just take note of the fact that we will be unable to use any strings in AngularJS. So we're going to be making use of some obfuscation techniques whereby we can use a string, but the web app doesn't realize that we're making use of a string. This is one of the reasons why the payload solution to this lab appears fairly complex and verbose. It's simply because we're trying to avoid using strings directly, and we have to make use of strings in a backdoor way so that it goes undetected. Okay, without further ado, let's access the lab. We have a blog and we have the ability to search the blog. Let's recap very quickly on JavaScript frameworks, in particular AngularJS. The idea is that content within curly braces gets parsed by the JavaScript framework. So for example, in the HTML markup for an app that's running the AngularJS framework, we might see two sets of curly braces. We might see some variable. This is referred to as an AngularJS expression, anything inside the curly braces. And this AngularJS expression is going to be evaluated against the app scope. And by scope, we simply just mean the variables and functions that are available within the AngularJS app. Sometimes this might be referred to as app state. When the page loads, this AngularJS expression is going to be evaluated and replaced with the appropriate variable or evaluation from the app scope. In previous labs, we were able to inject the curly braces into this search box. This is not going to be the case in this lab. We can't actually make use of curly braces in this lab, but it's good just to recap on how they work and what they do. Let's start by running an arbitrary search string in this search box, and let's see if we can find it in the DOM browser. We've searched for Zenshell. Let's search for it in the DOM browser, and we have some JavaScript, and in particular, this JavaScript is making use of the Angular object here, which has naturally been probably imported by some kind of CDN. We see that an Angular controller is being defined in the JavaScript. It has the name vuln control. The app is being passed scope, which is fairly typical. It's also being passed the parse method, which is a little bit less typical. You'd only pass that to the function if you needed to use it for something within the Angular controller. Let's take a look at what it's doing. First of all, it's defining a variable in scope. So it's saying scope.query is going to be an empty object. We're then defining a variable key, and that equals search. Notice that that is the key of our singular key value pair in the URL. What this means is really that there's a very good chance that this search is not hard-coded into the JavaScript. This JavaScript is created dynamically on the back end, and it's taking this first key value and using it as part of the JavaScript that's returned to the user client, the browser. In other words, the key of the key value pair is being injected into JavaScript. Now that's something that's very interesting to us. We're looking for an injection point. So the key of a key value pair seems like it might be an injection point. We're then setting scope.query at index key. And remember, key is evaluating to the string search. So scope.query at index search equals our search term. Again, you can see another example of why this JavaScript is being generated dynamically, because there's no way that they hard-coded my string into their JavaScript. This has been placed into the JavaScript based on the key value pair that we provided in the URL. And of course, that actually got there indirectly through us making use of the search bar there. We're then assigning to scope.value. And I suspect that it's this scope.value that's actually returned as part of this H1. Notice where it says 0 search results for Zenshell. Well, this string is obviously reflected because it was supplied by us, the user. I'm assuming that this is scope.value and it's being replaced by our search term. How do we arrive at scope.value? We're making use of that parse method. Remember, we saw it was passed to the Angular controller. We passed scope, which is fairly standard, but we also passed the parse method. So the obvious question is, what does parse do? It's obviously an AngularJS method. AngularJS parse takes a string, and this string is an AngularJS expression. It returns a function which is usually called directly and evaluated against a piece of scope. The scope is passed in the second set of function brackets, scope.query. Remember, scope.query has that index of search because search is the value of the key variable. So scope.query is passed as the scope. Which AngularJS expression is being evaluated? It's this variable key, which we know is actually the string search. So we're passing the string search to the parse method. That's our AngularJS expression. That search is then evaluated against the scope, scope.query. And we know that scope.query has this key of the value search, which equals Zenshell. In other words, all of this parse key scope.query is simply evaluating to our search term. Honestly, this seems a fairly roundabout way of doing things. There must be a much more efficient way of simply grabbing the user's search term and reflecting it to the page in a safe way. But as a result of this overly verbose approach, we see a superfluous or unnecessary use of the parse method. This is problematic because parse essentially evaluates an AngularJS expression. Remember, we were talking about these curly braces? Inside, we have an AngularJS expression, and that is going to be evaluated against the Angular app scope. Well, that's exactly what's happening here. We have a value being passed to the parse method. It's an AngularJS expression. It's being evaluated against scope. So although we can't make use of curly brackets directly, if we can inject into the value that's being processed by this parse method, it's essentially the same as being able to inject into curly brackets, because behind the scenes, the same thing is going to be taking place. This AngularJS expression is going to be evaluated against a specific piece of scope. So let's demonstrate that. Let's change our search key to 1. We're then going to make use of ampersand because we're going to add a second key value pair to this URL. And we know that it's actually the key itself that's going to be injected into. So let's set another URL key pair. We'll call it Zenshell, and we'll say Zenshell equals 2. Let's have a look at the results here in the DOM browser. So this is where things get a little bit bizarre in my opinion, because I have no idea what was going on in the head of the fictional developer here. This doesn't really seem to make any sense the way this is coded. What we see here in the JavaScript is that the code is iteratively processing all of the key value pairs. So we see the same script for the first key value pair. So we set the value of key to search scope.query at index key equals 1, scope.value equals parse key scope.query. Fine, that's what we saw before. Then we reassign the variable key to Zenshell, scope.query at index Zenshell equals 2, our search term. Then we're overwriting scope.value, parse method, we're passing key to the parse method. What is key? It's our injected string. Now, it's fairly benign at this stage. The string Zenshell is not going to do anything. And in this case, it returns our search term because we are exploring the scope.query at index Zenshell. And we know the value of that is going to be 2. So that's ultimately what ends up being assigned to scope.value. So we get 3 search results for 2. Okay, no vulnerability yet, but we have been able to inject an arbitrary string into the AngularJS parse method. One of the things we might do with these types of lab, just to get a feel for whether the lab might be injectable, and just to be clear, if this doesn't work, it doesn't mean the lab is not injectable, but it's an initial analysis vector you can make use of, and that is to pass a very simple AngularJS expression inside curly brackets, for example, 1 + 1. And if it's handled correctly, we're probably just going to get 1 + 1 echoed back to us. But if that expression is parsed by AngularJS, we might get the result 2 echoed back to us. Now, we mentioned that we can't make use of curly brackets in this search box, Part of the reason is when we search for something, it's ending up as part of the value of the key value pair in the URL. And as we've mentioned, we actually want to inject into the key. Let's see if we can replicate that 1+1 test in this second key value pair. Now we can't just place 1+1 in here, unfortunately, because plus has a special meaning in terms of URL. So we're going to need to URL encode this. The URL encoded value is %2b. So we have 1%2b1, 1+1, and we'll just change the value here because obviously that's 2 as well, so that could be misleading. Let's set that to 10. Now, if you were paying attention, you would see that before this value 2 appeared, we actually saw value load up in scopes. Now, there is a way of masking this if you're a developer, because obviously this is not great for user experience if you see the AngularJS expression before the page fully loads. But it's very clear that what we're seeing here is initially an AngularJS expression scope.value, or just value in between the curly brackets, and it's being replaced by the value 2. We've just injected into an AngularJS expression which was evaluated. Because we're not getting 3 search results for 1+1, we're getting 3 search results for 2, which means that AngularJS expression was parsed. So you may have noticed that we're now actually getting the value defined in the key of the key value pair and not the value that's being returned. Previously, we were finding that match in scope.query, but now that this key value has been parsed by AngularJS, we're no longer getting this match against the scope.query like we were previously. And the end result is that scope.value is just being given the value of key in this case, which is our 1+1 AngularJS expression, which has been parsed by AngularJS and is actually now returning 2. So the logical thing you might be thinking is, let's just replace that key with something malicious. So instead of 1+1, let's have our second key be alert function. Let's see what happens. Now, when we look at the JavaScript, we can see that our alert function was injected. We can see variable key equals alert. We then pass that to the parse method. So we're passing a string with alert function to the parse method. We're then evaluating that in the context of scope.query. So the question is, if alert is being evaluated by AngularJS, why didn't we get an alert pop up to the page? There's a couple of things to keep in mind. The first is that an AngularJS expression is not technically JavaScript. It is pretty much JavaScript when you look at it, but the idea is an AngularJS expression needs to be converted to JavaScript. So anytime we make use of the parse method, what's happening behind the scenes is JavaScript is run on that AngularJS expression. It's then compiled down to safe vanilla JavaScript. And part of the key idea here is that it's going to be safe JavaScript. So if there's anything not quite right with that AngularJS expression, for example, it's trying to make use of an alert function, that's not really the point of AngularJS. If a developer wanted to make use of an alert function, he wouldn't be putting it inside curly brackets. He would be launching that alert function via some other means. And this idea of checking an AngularJS expression to make sure it's safe for consumption is referred to as the AngularJS Sandbox. This is where the context/history starts to become interesting. There are at least 3 resources available through PortSwigger that you might want to read through to get the full understanding of the exploit here. The first one is simply the Academy documents on client-side template injection under the cross-site scripting section of the PortSwigger Academy. Notice what it says here. What is the AngularJS Sandbox? The AngularJS Sandbox is a mechanism that prevents access to potentially dangerous objects such as window or document in AngularJS template expressions. In other words, anything between the curly brackets or anything passed to the AngularJS parse method. The problem here is that every time AngularJS upgraded their sandbox to block some way of obfuscating or injecting a malicious payload, ethical hackers found a way to break that sandbox. And the history here is a long game of cat and mouse, where AngularJS upgrade the sandbox, the hackers find a way around that and manage to execute arbitrary JavaScript within the context of that sandbox. The next document you might be interested in checking out is the PortSwigger cross-site scripting cheat sheet. And there's a section here under Angular, and it talks about all of the different versions of Angular and how it was possible to bypass the sandbox. For example, 1.01 to 1.15, we have an example payload that could be injected between curly brackets. Just to give you a little taste of some of the logic here, we know that it's not possible to simply parse alert1 inside these curly brackets. The sandbox is going to pick up on that. It's not going to execute the JavaScript alert. So here is a basic level workaround. We make use of this global constructor method and look at .constructor, which in JavaScript is actually a function constructor. In other words, it's a function for making functions. It accepts a string, so in this case, alert1. In other words, we're creating a new function, and that function is going to execute alert1. So this returns a function. We then have some extra function scopes because we want to call that function directly. So if we just pass alert, the sandbox is going to pick that up. If we call alert in a very roundabout way where we create a new function and then call it using this constructor.constructor, it's very, very strange looking JavaScript. You'd never actually use this type of JavaScript in a normal app. We're basically finding a way to backdoor into using the alert function so that the sandbox doesn't detect what we're trying to do. And this is really the same pattern that you're going to see in all of these sandbox escapes. None of this is JavaScript that you'd actually use as a developer. It is valid JavaScript. We should be able to figure out what it does, but it's deliberately obfuscated JavaScript that's going to confuse the sandbox and execute arbitrary JavaScript as a result. That's why it's referred to as a sandbox escape. We're supposed to be operating in this contained, safe environment. That's what a sandbox is in computer terms, a safe, contained environment. But obviously that's not the case if we can find a way to break out of the sandbox and run arbitrary JavaScript. Now this created a problem, and as an end result, the sandbox itself was actually removed from AngularJS. The problem here is that the sandbox was providing a false sense of security. So developers might have gotten the idea that they could run any code that they want, and it's impossible for that code to be hacked because the AngularJS sandbox is going to protect them from any malicious actors. But as we've seen time and time again through the cross-site scripting cheat sheet, it's always been possible to bypass the sandbox. So it wasn't really adding any additional security, but it was potentially encouraging developers to be somewhat lax with their approach to security because of this false idea that they are going to be protected by the AngularJS sandbox. As a result, it was removed. Now you can see there's numerous examples of ways to bypass the sandbox. It does depend on the version of AngularJS. And in particular, one of the reasons why PortSwigger features AngularJS in their labs with a high frequency is because they were involved in this game of cat and mouse. We have this researcher here, Gareth Heyes, part of the PortSwigger team, and he actually has a write-up on breaking out of the AngularJS sandbox, which is the third document you might want to take a look at. So this is now the much deeper dive on what's happening behind the scenes with a specific sandbox breakout. You can see that ostensibly the article is about client-side template injection, but it very quickly gets into the AngularJS sandbox, talks about how AngularJS expressions are being parsed, and how exactly the logic of breaking out of the AngularJS sandbox works. Looking once again at the cross-site scripting cheat sheet, let's see if we can find the specific exploit we're looking for. It's this one here, 1.4.4, which is the version of Angular that is being run. Notice Gareth Heyes from PortSwigger team, and the write-up we've just looked at actually features this particular exploit. Let's take a look at what the exploit does, because this is what we're going to be making use of in our lab. Now, this is not really a sandbox bypass as such. This particular piece of code actually breaks the sandbox, and then we can essentially just walk out of the sandbox afterwards. So it's not a clever obfuscation or bypass. This basically just destroys the sandbox itself by overwriting one of its key functions, allowing us to fairly arbitrarily step out of the sandbox. So it's not really a sandbox bypass, it's more of a sandbox demolition that we're looking at right now. The way it works is by overwriting the character at method on the string function in JavaScript. So we're calling toString. We're looking at the constructor, which is going to be the string function itself in JavaScript for creating strings. We're looking at the prototype. In other words, all inherited methods and properties that the JavaScript string function is inheriting. We're looking at this char@at method, and we're overwriting it with array.join. Now, the idea with char@at method is that it returns a single character from a string, whereas array.join, well, looking at the MDN docs here, we can see that array.join returns multiple characters. You can see an example of it being used here in MDN. So we have elements array, fire, air, water. Elements.join with nothing passed as the argument. We see that we get a string. The array is basically being converted into a string here. So rather than get a single element from the array, we're getting all of the items from the array. And when we look in JavaScript, strings function very similarly to arrays. So the end result is char@at should be returning one character from a string, whereas array.join is going to be returning everything from the string. And the reason why this is important is when we look at the JavaScript as part of the sandbox, it makes use of this char@at function to try and determine whether an AngularJS expression is safe. It uses this char@at method to go through each character in the AngularJS expression and look for any red flags that indicate that this is not a safe AngularJS expression. If we look further at Gareth Heyes' writeup, we can see an explanation, or at least a small window into what's happening on the back end when the AngularJS expression is being checked. We have this isIdent function, and the idea behind isIdent is that it's supposed to take a single character, and if everything looks okay with that character, then this expression is going to return true. And if we take a malicious payload, well, we're going to get a return false at some point, and the evaluation of that AngularJS expression is going to be terminated because the expression is not safe. But because the sandbox is making use of char@at to pass values to this isIdent function, what ends up happening is that instead of receiving a single character as the argument for this function, it's actually receiving the entire string. So for example, instead of a single character being passed to isIdent, we might get an entire string as the argument. The problem with passing multiple characters to this function is that if you evaluate the logic, it's always going to return true. When you look at this function, we won't go through it right now, but just keep in mind that there is an order of operations here. So any AND is going to take priority over OR. So this has to be true, and either this or this needs to be true, and either this, or this needs to be true. So if you read this incorrectly, it's not going to make sense. If we're assuming that this and this need to be true, or this and this need to be true, that's actually the incorrect order of operations. If you don't want to get into this too much, that's fine. Just keep in mind that anytime you pass multiple characters to this isIdent function, you're always going to get true as a result. In other words, the sandbox is no longer doing what it's supposed to be. And that's because under the hood, it makes use of some core JavaScript functions, which we've now actually overwritten with the first part of the payload. So that's the end of the first part of our JavaScript. We can see it's delimited there by a semicolon indicating the end of that line of JavaScript. We then have a second line of JavaScript, which is going to be the exploit itself. Now, this is an AngularJS expression. Remember, it's not technically JavaScript, it's an AngularJS expression. So when we look at an array followed by a pipe character, Well, in JavaScript, the pipe character is referred to as the bitwise OR operator. That's not what this is. That's what it would be if this was JavaScript, but it's not. It's an AngularJS expression, which is very similar to JavaScript. One of the differences is that in AngularJS, this pipe character is referred to as an AngularJS filter. Simple example here is, as the developer, you might have an array that's being placed inside curly brackets, but we want to sort that array in a specific order, or we want to exclude certain items from that array, or only return a single item from that array. We can make use of the filter. And the filter that's being made use of in this case is the orderBy filter. So it's, as the name implies, this particular filter is designed to allow you to sort the array before returning it to the view. Now, you might be wondering why we actually need the filter in this case. And the simple answer is it's simply part of the obfuscation technique. We're going to find that if we try and execute our malicious JavaScript directly, it's not going to work. But one of the ways that we can get around that is by including our malicious JavaScript inside the AngularJS filter, as opposed to including it directly as part of the expression. Again, you'd never write JavaScript like this. We're doing it deliberately to obfuscate the payload in this case. This is something that was just tested and it worked. It was a way of breaking out of the sandbox. And there's a number of questions that you might have regarding this payload, which we won't cover explicitly. But very often the answer to why have they specifically written the JavaScript that way? The answer is because if they didn't do that, it's not going to work. It's going to be detected by the sandbox. So anything that looks weird or out of place, it's deliberately written that way so the sandbox doesn't pick up on this being malicious JavaScript. So we've included this orderBy AngularJS filter, and it generally accepts a string. Now, we did mention at the outset of the lab that we can't make use of strings. This is not necessarily something to do with AngularJS. It could just be something to do with the web app itself. For example, let's see if we can inject a string, making use of double quotes. What we can see very clearly is that those double quotes are being HTML encoded. Even when we look in the JavaScript itself, we see the HTML encoded version of those double quotes. So this might not be an Angular thing, probably more to do with the web app itself, but the end result is the same. We can't make use of strings directly. We can't simply just include a double quote and then place our string inside the double quote. Depending on the vulnerability, in some cases, you might be able to do that. But in this particular lab, we can see that our double quotes are being HTML encoded before they're being placed into the JavaScript. So we can't just inject double quotes. They will be HTML encoded. But just because we can't use double quotes doesn't mean that we can't make use of strings. Once again, we just need to obfuscate the procedure, use some type of backdoor method to generating a string. And that's what this is. We're using toString.constructor.fromCarCode. So toString.constructor is going to return the JavaScript string constructor function. And on that function lives the method from CarCode. What does from CarCode do? We can see the description here. From CarCode static method returns a string created from the specified sequence of UTF-16 code units. So there's obviously a string being created here. Let's rewrite the character codes on the MDN web docs here. Let's see what we're getting with this particular string. Let's choose run. So you can see the character codes there spell out the string x equals alert 1. And the objective of the lab is to pop up the alert in this case. So in Angular terms, what is this doing? It's taking the array, you can see it has two values, 1 and 2, and it's ordering them by a string. And that string equals x equals alert. So we've removed the character codes just to make things straightforward. We have an array, orderBy, x equals alert. OrderBy is supposed to take a string. So the question is, how exactly does x equals alert help us to orderBy? And the answer is really, it doesn't. All it's doing is running the code x equals alert for each item in the array. So if there's 2 items in the array, it's going to try and run x equals alert twice. And naturally, it's going to order the array based on the return value of the code that's executed. So it is supposed to be a string, but the code inside the string will be executed. When we have an assignment in JavaScript, it returns undefined. In other words, it's going to evaluate this expression, that's going to return undefined. It's then going to use undefined to sort the array. Obviously, undefined is not going to change the order in any way. So we're actually not trying to use the orderBy functionality here. We don't care about that. But what is happening, x equals alert, is going to be executed, which is the key idea here. Now, one of the most obvious questions that you might have from this is, what is that x equals about? Why do we need x equals alert? Why can't we simply just call alert for every function in the array? Remember how we mentioned earlier that there are many questions you might have like this, and in most cases the answer is simply going to be, if you don't do it this way, it's not going to work. It's going to be picked up by the sandbox. When we do things this way, the value of alert is considered, the return value of alert, which is not going to be anything useful. So although alert is still executed, the alert pop-up to the browser is suppressed in this case. We don't have valid cross-site scripting attack. Remember, we said this is about obfuscation. As soon as we instead change this to x equals alert, well, in order to assign a value to x, alert needs to be called, but this time that alert pop-up is not going to be suppressed. In other words, it's x equals alert because this is how we actually get around the sandbox in this case. This is why Gareth Heyes, the PortSwigger researcher here, has included x equals alert as part of the string, because if he didn't do that, then it's not a valid sandbox escape. So is it weird JavaScript that you'd never write? Absolutely. Is it necessary in order to bypass the sandbox? Yes, because if we just have alert, then the sandbox is still managing to suppress that despite the fact that we've overwritten this car at method. Initially, when I looked at this payload, I figured maybe from car code was actually using car at under the hood, and that's why this particular payload works. But that's not the case. The case here is very simply that when we overwrite the car at function, it breaks the fundamental way in which the sandbox works, which then allows us to get AngularJS expressions with malicious payloads through when we ordinarily wouldn't be able to do that. So from car code doesn't really have anything to do with car at, but because we've broken the functionality of the sandbox by overwriting car at, we're now able to get an unsafe expression through. So ordinarily, this from car code with x equals alert shouldn't work, but obviously under the hood, Angular is taking this expression, it's running it through the sandbox security checks, and as part of those security checks, it's making use of this car at function. Car at is supposed to return a single character and pass it to the isIdent security check on the back end. But because we've overwritten that with array.join, we're passing multiple characters to that isIdent function, and we're getting a return value of true. In other words, we're passing the security checks with a payload that shouldn't pass security checks. So step one here, break the sandbox. Step two, exploit the fact that we can get a payload through the sandbox, which shouldn't be able ordinarily to get through the sandbox. Taking a look at the solution to this lab, we can see that we don't actually need more than one value in the array. A single value is fine. Let's copy this payload. Now, I don't recommend copying and pasting payloads. Generally, the key is to understand the payload, but we've hopefully considered this in depth at this stage. So really, it's the only thing that remains is just to paste the payload in. It's the exact same payload that we've looked at in the cross-site scripting cheat sheet. The only difference is we have a single value in the array. The second value in the array is not necessary to make this exploit work. So you can see we get the message, congratulations, you solved the lab. We should also get the alert pop-up. For some reason, we don't get the pop-up in this case, although this is the lab solution and it's ordinarily accompanied by an alert pop-up. Now, if we take a look again at the solution write-up, this honestly does not make a lot of sense beforehand unless you already know a lot about Angular sandboxes and breaking out of the Angular sandbox. Hopefully, in the context of everything we've looked at, the write-up should actually make sense now. Let's read it as a summary. The exploit uses toString to create a string without using quotes. It then gets the string prototype and overwrites the car@. function for every string. This effectively breaks the AngularJS sandbox. Next, an array is passed to the orderBy filter. Remember, this is something specific to AngularJS. We then set the argument for the filter by again using toString to create a string and the string constructor property. Finally, we use the fromCarCode method to generate our payload by converting character codes into the string x=alert. Because the car@. function has been overwritten, AngularJS will allow this code where normally it would not. That's why it's referred to as a sandbox escape. Okay, so hopefully everything makes sense. Remember to check out this document from Gareth Heyes if you want to go in depth. There are some JS fiddles that have been set up there. So the idea is you can follow them through, set certain breakpoints on the code, and get a deeper dive on how exactly the AngularJS sandbox is functioning under the hood. There's also an implication here that the alert might not be working because we're specifically running this in the Firefox browser. We might need a slightly different payload for Firefox, or it might not work, period. As you've seen, we were still able to solve the lab in Firefox, but we didn't actually get the alert popped up, which is honestly kind of the whole point with a cross-site scripting attack. So if you are also not getting the alert, then feel free to try this attack in a different browser and you should succeed. But ultimately, you don't need to do that in order to complete the lab. As you've seen, we were able to complete the lab on PortSwigger's side without the alert being popped up. So if you're comfortable with just knowing that in theory, the alert should pop up in a different browser, that's fine as well. Thanks very much for watching, guys. Hopefully this is a bit clearer now. It's a slightly deep topic and there's definitely a lot more that you could explore here. Catch you guys in the next lab.